Oh, you're fine. I actually have some background music on. Can you guys hear me all okay? All right. Okay. So this will also play at the end. A little too loud.
Nearly 2,000 years after the eruption, the preserved remains of the inhabitants of Pompeii were discovered and excavated.
How's that? Can you hear me okay?
Awesome.
Okay. All right. So I've got a little background music. It's by Volcanoes, or called Volcanoes by the Amoeba People, which is a really good, if you like geology and funny geology music, Amoeba People, really good band. And we'll play that afterwards. So welcome to the Lizadra Museum. My name is Sara Kurth. I see some new faces and I see some old faces. So first of all, a little bit of information about me. I am a geologist. My background is actually in volcanology, specifically magmatic geochemistry. I have my master's degree from Central Washington University out in Washington State, and I did my undergraduate degree at Beloit College in Wisconsin. I have a geology degree and a museum studies minor. I have been at the Lizadra Museum as the educator for 15 years in August. Before that, I was actually an intern here when I was at Beloit. So I've been here forever. I'm the bad penny they can't get rid of. So I'm not technically a physical volcanologist. I am more of a geochemist. So my background is looking more at the lava after it's been erupted to see what was going on in the magma system after, during, and after eruption. So I am not the person who goes out there with the tin can and collects the lava, but as you can see, I have done that, just more on a personal, fun level, not for any scientific pursuits. Although I will say, you can see this is a picture of me when I was in Guatemala, and in Guatemala, they don't care what you do. And I was able to walk on lava, and I very poorly chose to wear sandals. Yeah. So so my shoes did get melted, but more importantly, as I was walking on lava, and we'll talk about this a little bit later, but lava cools from the top down. So it can be nice and solid on the top, but underneath is still molten. And so when you're walking on lava, it might crumble under your foot, and that happened to me. And I very quickly pulled my foot and cut my toe on the lava, which was really exciting for me because I actually bled into the lava. So now my DNA is forever encapsulated in that lava in Guatemala. And so in 1,000 years, some geochemist is gonna come along and be like, why is there human DNA in this? Actually, no, but that's my little word of wisdom is.
Someday you're going to be a volcano.
Exactly. So that's a little bit about my background and who I am. So we'll get right into it. So, and these are the places I've studied. So I did my undergraduate work in Iceland, which was awesome. And if you like volcanoes or you just like geology, Iceland is the place to go. And then I did my master's thesis work on Mount Bachelor in Oregon, which is where the US Olympic ski team likes to practice skiing. So this is my mountain, Mount Bachelor. And in Iceland, I actually had 3 mountains that I studied the chemistry of the lavas on. So that's a little bit about me and my background. And so we'll jump right into it. So what are some of the volcanoes you have heard of? I just mentioned a couple, but what have you heard of? So the Cascade Line, yes, the whole Cascades, yes, which includes Mount Bachelor, my mountain. Where else? What was it? Mount Vesuvius, which killed the people of what town? Pompeii. So Pompeii was the town. Vesuvius was the mountain that erupted. What else? Or the volcano, I should say. Krakatoa, yep. Pinatubo, yep. That was in 1991. Anything else you can think of? Fuji, yep, Fuji in Japan. The Hawaiian Islands, do you know what the active ones are? The active one, I should. What- I heard it. Kilauea. But Mauna Loa has been having a little bit of activity lately too, so we'll talk about that as well. So I think you guys got all of mine. So Mount St. Helens in Washington, its last major eruption was in 1980. It's had a little bit of activity since then, but nothing to the scale of the May 1980. Mauna Loa in Hawaii, so it was active from 1843 to 2018, and then it had 12 days last year where it was actually active, so there was lava coming out. And it is actually the largest above ground volcano on Earth. Mount Vesuvius, which caused the destruction of Pompeii in 79 AD. And right now there's actually an exhibit, I have not yet been to it, but there is an exhibit at the Museum of Science, Science and Industry about Pompeii. So one of these days I will get to that. But so that was the one everybody knows about. And Mount Pinatubo in the Philippines, which last major eruption was in 1991. There are even volcanoes on other planets. So that is Olympus Mons, which is on Mars. And we think that it's about 2 million years old, and it's 3 times the size of Mount Everest. Is Mount Everest a volcano? No, it is not a volcano. It is just a mountain. It's just a plain old mountain. But here we can see, if my laser is not the best on this screen, but you can see this is Olympus Mons on Mars. This is Mount Everest, and this is Mauna Kea, which is similar to Mauna Loa. They're about the same size range. Why do you think Olympus Mons is so much larger than all of the mountains and volcanoes here on Earth? So when you say wind, what do you mean by wind? Erosion. So there is dust storms. There are dust storms on Mars. And actually, we can see a little bit here. So there is a little bit of erosion going on, but not to the extent that happens on Earth. Why? What's the difference between water? That's it. So there is not flowing water that we know of on Mars, whereas here on Earth, we have lots of flowing water. We have wind, we have rain, we have sleet, we have snow, we have ice. All of that is really good at breaking down rocks. What else is different between Mars and Earth that would make that volcano less eroded? So there is less gravity on Mars, that's true, so when it erupted, but we're talking 2 million years. That's a long time. We don't have any volcanoes still visible that are that old on Earth. What else is on Earth that's not on Mars to our knowledge? Life. So life is really good at destroying rocks. Something that life does the best. And not just us. All life destroys rocks. You see rocks out in the world and you see lichen on it. Lichen is a geologist's worst nightmare. We scrape that off to try to see the rocks themselves. So life is really bad for rocks and really good for erosion. So there is no life that we know of on Mars to break down that rock. So the rocks on Mars just don't have quite the erosional influence that is on Earth. Make sense? All right, so that's all I know about other volcanoes on other planets, so we're gonna come back to Earth. And on Earth, there are about 1,500 active volcanoes during the past 10,000 years. So again, erosion plays a big factor in that. We may not necessarily know past volcanoes. Maybe we have evidence of ash flows or we have evidence of lava, but we don't have the actual volcanoes or magma systems to know what was going on in the past. In the US alone, there are 169 active volcanoes, 54 of which are at high or very high threat to public safety. And at any given time, there are about 20 volcanoes erupting. So to give you a bit of an idea, this is a real-time map of active volcanoes. So this is a website you can go to, and you can see different volcanoes, see what's going on. The yellow means that they are in a state of unrest. An orange is a warning, and red means it's actively erupting. So I need a volunteer. Come on up and point out a cluster of volcanoes. So about 10 is what I define as a cluster. What do you see? A cluster of about 10 or more. Okay, so over here in the Indonesian area. All right, awesome. Have a seat. Another volunteer. Come on up, my friend. Show me another cluster. About 10 or more. All right, yep, so we've got South America and on up into Central America. One more volunteer? No volunteers?
I don't walk well enough.
That's okay. So I'm going to just point out one more cluster right over here, and then up here into the Aleutian Islands. So what do we see here? The Pacific Rim, also known as the Ring of Fire. So the Ring of Fire encircles what? The Pacific Ocean, which has lots of what? Water. That'll be important in a little bit. I'm not just asking stupid questions for fun. So the Pacific Rim, or the Ring of Fire, encircles the Pacific Ocean. So the Pacific Ocean plate, I should say. So the Earth is made out of lots of different plates, and they all move around. Ocean plate tends to be a little bit denser than continental plate. So North America sits on the North American plate. There's the South American plate. Some of these plates are actually broken up into smaller plates. So off the coast of Washington and Oregon is the Juan de Fuca plate. But so for the most part, we have just big plates, and they move all around. And right here is where the ocean plate, the Pacific plate, is hitting continental plates, which causes subduction. So subduction happens, a denser plate hits a more less dense plate, and the denser material will get squished down underneath the lighter material. So that's what we call subduction. So we see lots of earthquakes and lots of volcanoes along subduction zones. What's this right here? Hawaii. So if we zoom in and click on it, this is Kilauea volcano in Hawaii. This is sitting in the middle of a plate, sitting in the middle of the Pacific plate. There is no subduction going on here. It is a weirdo. And we'll talk a little bit more about that. But this just gives you kind of a general idea. There's some other plates going on over here. That's why we've got a lot of volcanoes in Italy. The Canary Islands are having some fun right now too. Occasionally you'll see Iceland, but right now Iceland's pretty quiet. You can even see volcanoes in Antarctica, which is pretty cool. So this is a really cool website. I'd be happy to send this on to anybody, but you can actually click on the place and see webcams and watch what's going on, all sorts of fun data. And if you'd like, I could just send an email to everybody after so if you registered online, I'll just do that. A little bit easier than trying to write it all down. Yeah, so this is a really fun way to see what's going on. If you hear about volcanoes in the news, you can hop on this site and see what's going on. I know right now Etna has been having some fun, so you can see what's going on, how long it's been erupting. So this is kind of a fun website. But it shows really well this ring of fire, this area where we see a lot of volcanic eruptions, and as well as earthquakes. So you can actually see earthquakes as well. Earthquakes and volcanoes do kind of go hand in hand, but not always. I like the volcanoes, so I always hide the earthquakes. But we sit a little bit north of the New Madrid Fault. Has anybody heard of the New Madrid Fault? Something we should probably be aware of. And if and when that ruptures, that will be, may not be such a big deal for us here, but it is something to be aware of. Questions about this before we move on? All right, so we're going to come back to here, and we're going to talk about the different types of volcanoes. And there are lots of different smaller categories, but I'm just going to cover the three main ones. So cinder cones are what you think of when you think of a volcano, that's steep-sided with the cone on top. Has anybody here been to Wizard Island or Crater Lake in Oregon? All right, so Wizard Island is a composite volcano. These volcanoes are very short-lived and they can be very explosive, but they don't last very long and they don't affect a huge area. Wizard Island is actually kind of interesting because it's of two volcanoes in one. So Wizard Island sits inside of a caldera. A caldera is what happens when a volcano erupts so completely that the only thing that is left is a giant hole in the ground. And that volcano that formed Crater Lake, or the caldera of Crater Lake, was called Mount Mazama. So we have two volcanoes in one. The cinder cone is, Mount Mazama was a very different kind of volcano. Wizard Island is a cinder cone. It is not active and hasn't been active for a very long time. So Mount Mazama was actually a composite or a stratovolcano. Both names are okay, but these are very explosive with long periods of dormancy. So they will erupt, and they will erupt a lot of material and affect a large area, and then they'll be quiet for very long periods of time. The reason they're called stratovolcanoes is because the material builds and builds and builds until you get these very large mountains, upwards of 8,000 feet. So Mount Rainier and Mount St. Helens are both composite volcanoes. Mount Rainier has not erupted in a very long time, and it is due for an eruption. Mount St. Helens has been letting off steam, but the last major eruption was, of course, in May of 1980. And last but not least are the shield volcanoes. So these are volcanoes that last for very long periods of time, but don't have that high explosivity. So they're not very dangerous, if you will, so they don't produce a lot of ash and destruction, but they produce a lot of material. So it's a lot of lava just pooling on top of itself until it gets very, very large. So it forms this shield. So you can see how it kind of looks like a shield in armor. That's where it gets its name from. And these are actually the largest volcanoes on both Earth and Mars. Mauna Loa, which is pictured here, is 28,000 feet high if we were to measure from the bottom of the ocean to the very top of it. But half of it is underwater, so we don't see that. So to give you kind of a better idea, this on the top is Mount Rainier next to Mauna Loa. So Mauna Loa is this giant shield volcano with a lot of it underwater, very little, like just the top of it above water. And you can see where Mount Rainier falls into the size of Mauna Loa. So incredibly large amount of material forming these shield volcanoes. And then if we compare Mount Rainier, the composite volcanoes, to Wizard Island, the cinder cone, you can see Mount Rainier is much larger. Okay, so we go from very long-lasting volcanoes with very low explosivity all the way to the highly explosive, but they last a very short amount of time, and halfway in between are the very explosive, followed by long periods of inactivity. So that's kind of a general comparison of some of the main volcano types. Does that make sense? All right. And what really makes these volcanoes different is how they erupt. There's two kinds. There's the explosive and the effusive, also known as red and gray. So gray volcanoes are the explosive volcanoes. They're the ones that produce a lot of material. They have lots of gray smoke, gray ash coming out, versus the red, which is just layers of lava building and building and building. That's not to say that an effusive eruption can't have an explosive eruption periodically. Kilauea and Mauna Loa have both had ash come out. But for the most part, these effusive eruptions are relatively quiet eruptions, and they just produce a lot of lava. Whereas the explosive volcanoes are very violent and can be very damaging. I went the wrong way. Okay, so let's talk about explosive eruptions first. What happens if you take a can of soda and shake it? You won't open it, unless it opens itself, which is what happens here. So what happens with a can of soda is they take the soda and they inject carbon dioxide, the atmosphere, into the can, and that's what gives you that bubble taste, that carbonation. So it's actually dissolved gases in the can that makes carbonation. The same thing happens with our volcanoes, but instead of injecting carbon dioxide, we're injecting water. So we're thinking about the ring of fire and the subduction zone. That subduction zone, the Pacific plate is going underneath the continental plate. That ocean plate has lots of water, and that water is getting dragged down into the subduction zone. That water acts like our carbon dioxide in our soda can. So it's actually, we're injecting water into our magma system. That water will eventually build up so much pressure that our can explodes, just like with a volcano. So as the more water that builds up, the more pressure we get inside of that volcano, eventually we will get a volcanic eruption, an explosive eruption. Make sense? So think of an exploding soda can when you think of Mount St. Helens eruption. That's exactly what's happening. As opposed to the effusive eruptions, which is more like warm honey, where the lava is just kind of warming up and flowing out. So these volcanoes can last for decades. Kilauea crater erupted for 35 years. So that was from 1983 to 2018. It had a little bit of a, it had that big, huge event in 2018, and then stopped erupting. And then in 2020, a new crater started. So I'm going to try to pronounce that. The Halemaumau is the current crater that is erupting right now at Kilauea. So it's all the same volcano, but different points where the lava is erupting out. And I will say Hawaii really threw me for a loop. I was expecting that Kilauea would stop erupting and a new seamount that is forming off the coast of Hawaii would actually start producing more material, and eventually that would become the new Hawaii, the new magma system. But geology doesn't like to play by any rules except for its own. So now we've got Kilauea back erupting, and Mauna Loa decided to throw around for a little bit. So, you know, Hawaii is all kind of crazy right now. But it just shows that these volcanoes do what they're going to do based off of whatever is going on inside, which is why we need to understand what's happening, because then we can better predict. So Hawaii is what we call a hotspot. That's why it sits in the middle of that Pacific plate, right here. And in that map, you can actually see past Hawaiian islands, islands that were formed by this hotspot. So Hawaii's here now, but we actually have the Emperor Seamount Chain and these old Hawaiian islands. These are all from the same hotspot. Does anybody know what happened here to make it kinked like that? Which plates? Actually, well, there were plates moving, yes. And it was actually when India crashed into the Eurasian plate. So when you have two continental plates, they won't subduct, they move up, and that's where Mount Everest comes from. It's actually two continental plates crashing into each other, and it jerked all of the plates around. So everything's connected. So if you move one, another plate will move. And you can actually see this with Hawaii. We can actually see it also with Yellowstone, which is really interesting, and we'll get to that in a little bit. But all of these islands here were part of the Hawaiian hotspot. Hotspots are just, for whatever reason, magma coming up from the inside of the earth, from the mantle. We don't know why. At least I've been out of school for a while, but I know research has been going into that. Well, that's why I studied in Iceland, was to understand hotspot interaction. In Iceland, the rocks are actually interacting with a ridge. So instead of plates coming together, the plates are coming apart. In Iceland, there's a hotspot and that ridge. So both of those happening together, which is really weird. And why these hotspots are forming, we don't know. And that would be something, if you're interested in looking more into. Our younger generation can study that. It's just really hard. We can't get to the mantle, and we can't get to the core of the earth to know what's going on. So the best that we can do is use seismic waves to see inside of the earth as best we can, but it's really difficult to study hotspot geology, but it's very interesting. I know that's kind of confusing. Are there any questions? No? Okay. So Yellowstone is also a hotspot. We'll talk about Yellowstone in a little bit, and Iceland is that unique two different types of volcanism happening at the same time.
It keeps talking about rhyolite.
Mm-hmm.
What is rhyolite?
So rhyolite is a type of lava, and actually I have a piece here. So rhyolite is a sticky lava. So it's equivalent to granite, but it gets erupted out of the volcano. So a normal Hawaiian lava is like this black basalt. A rhyolite is got quartz in it. It has a higher amount of quartz, and it has higher amounts of sticky minerals. So quartz is a sticky mineral, minerals that don't just flow out. So lava, black lava like this, salt, is very flowy versus a rhyolite, which is a little bit more of a sticky. Why that happens can be for several different reasons, but mostly just the magma system has been sitting for longer, so more crystals are able to grow and get larger, and you get more quartz material in that lava. That's a good question. We'll talk a little bit about Yellowstone specifically and what's going on there. Other questions? Okay. So let's talk a little bit about volcano hazards, because this is what everybody really wants to know about. The most dangerous part of a volcano is the pyroclastic flow. So from 1600 to 1899, most fatalities from volcanic eruptions happened because of famine. And this was because we didn't have the technology that we have today to save our food, to store our food, to transport our food. And then starting in 1900 to 1986, it's a little dated, most of the fatalities of volcanoes happened because of a pyroclastic flow and a lahar, but mostly from pyroclastic flows. So a pyroclastic flow is a hot, fast-moving cloud of gas, ash, and rock debris. We call that rock debris tephra. So when you look at this picture, you can see how tall it can get. Pyroclastic flows can either go straight up into the air, or they can blow out the side of the volcano. That's what happened with Mount St. Helens. Instead of going up, it went down. So it had actually gravity working in its favor, so it can move much faster than going up into the atmosphere. So this is a video of a pyroclastic flow. This is from, I think, 2021 or 2022. So you can see it flowing down, this cloud of ash and rock and debris flowing down the mountain. It's not just gas, no. Yes, so the material of a pyroclastic flow, we call it tephra. So it's everything that's inside of that. So it could be gas. There's a lot of sulfur, but it's a lot more of other stuff. Did you have a question? I'm sorry, my friend. Oh, no, okay. So it's a lot of other stuff as well. So the biggest thing is volcanic ash. So you can see in this picture, it gets everywhere. You can't breathe in this ash. This is not like wood ash, like if you have a campfire. This is rock ash. Does anybody use a pumice stone? A pumice stone to get the dead skin off your feet? This is volcanic ash. So you use rock ash to get dead skin off of your feet. This is actually ash from Mount St. Helens. So it's very fine. You can't open it because it will get everywhere, but it's very fine material, and you cannot breathe this. You can't have your airplanes go through it. You can't have your cars go through it. An inch of this on the roof of your house mixed with water will cause your roof to collapse. This is very dangerous stuff. This is actually what killed the people of Pompeii when Mount Vesuvius erupted. So this is pumice after it's been turned into a rock. Before it's turned into a rock, it's that fine material that just gets everywhere. So when Mount St. Helens erupted, they actually took some of that ash and turned it into a lapidary material, but people were brushing it off of the streets, even as far as 100 miles away.
How long does it take for the pumice to actually form?
Some of it will actually already be preformed as it comes out of the volcano. So some of it will be broken up like that. Some of it will have been so hot that it solidifies as it comes out of the volcano. So some of it's already preformed. So there was a story in the 1980s, I believe, of an airplane that tried to fly through an ash cloud in Indonesia, and the pumice, the ash, coated the airplane propeller and caused the propeller to stop, which caused the plane to start to nosedive down. Fortunately for the airplane, the going down part cooled the engines enough to re-solidify that ash, and then the plane was able to right itself and land safely. So nobody died in that situation. But then we learned, don't fly through an ash cloud. It's not your best choice. So if you've ever heard about a volcano is erupting and you can't fly to Europe or you can't fly over the Aleutian Islands, this is why. You cannot fly through this. You can't breathe through this, and you cannot drive through this as well. So this is one of the more dangerous parts of the volcanic ash. And there's also volcanic or lava bombs, which get erupted out as well. So these are just blobs of lava that as they fly through the air, they start to solidify, but inside there's still molten material. So it's essentially a bomb being thrown out of the volcano. This is a relatively big one. It can be small ones as well. So here's a video. What I want you to notice is the little pieces are flying, and this photographer was just a little too close. He is okay, but yeah, he was a little too close for comfort for this. So you can see those little blobs. Those are lava bombs being erupted out. You can hear them too.
Wow, das war knapp.
And there you go. You can still see, pause this right here. You can still see it's molten on the inside. So as it's coming down, it's cooling, and it gets that shape from that first slide. It gets that shape from the wind resistance, but when it crashes, it can literally explode like a bomb, and it's still molten lava. So tephra includes that ash, the volcanic ash and pumice, as well as these lava bombs. Okay, so pyroclastic flows, stay away from them. If you hear about a volcano erupting, this is what you do not want to be near. All right, wrong direction. All right, the next most common fatality in this day and age are lahars. So this is Mount St. Helens after it erupted. What do you see on the sides of Mount St. Helens? Well, you see the mudslide now, but what do you see on the sides of the volcano? Snow and ice. So a lot of these composite volcanoes are so high up that they actually have snow and glaciers on the top of them. And so if we have a volcano erupting and we have hot material interacting with that snow, what's going to happen to that snow? It's going to melt and it's going to go down. So it's going to mix in with that lava, it's going to mix in with all the debris, and it likes to flow down into riverbeds, river streams. Where do we like to build our cities? By rivers, right? So Mount St. Helens and Mount Rainier both are these composite volcanoes with lots of ice and snow on top. In fact, Mount Rainier, they used to bring airplanes and land them on the top of the mountain, and then they couldn't get one of them off, so there's actually an airplane that's stuck under the ice up on the top of Mount Rainier. So when both of those volcanoes erupted or will erupt, that ice melts, turns into a mud slurry, and flows down the side of the mountain. So I want to preference this video next. The guy gets out of the way. It doesn't look like he's going to get out of the way, but he does. So that you can see how fast
Tu peux te pousser, monter un tout petit peu,
it
s'il te plaît?
moves. And it has the consistency of concrete flowing about 60 miles per hour down the mountain. I believe so. It is. All right. So when Mount St. Helens erupted, a lot of the damage was more from the lahars than from anything. Yeah. It is hotter. So you can actually see the steam rising off of it. So, I mean, you wouldn't want to go swimming in it, but it's not going to be as hot as the lava. It will have started to cool off, but it will be steaming. So yes, you can see the steam coming off of it. And it's, again, the consistency of concrete. So again, wouldn't want to swim in it. That would not be good. So the town of Tacoma, Washington sits on deposits of lahars from past eruptions. So we in Illinois have the tornado drills where we go inside and cover our heads. In Tacoma, they actually have lahar drills where the kids leave school and go up higher to high ground to get away from the river system. So the entire town of Tacoma, Washington sits on past deposits of lahars from Mount Rainier. So definitely a dangerous place to be if and when Mount Rainier goes off. Fortunately, when Mount St. Helens erupted, they had enough knowledge that it was going to happen that most people were able to get to safety. There were some holdouts who did not want to, but you know, that's going to be how it is in every situation, but that's why eruption prediction is so important. And also the not to call wolf. So the problem is if you say, oh, there could be an eruption, and then that doesn't happen, you put a lot of people on alert, and then they don't take you seriously when it actually is going to happen. So that's something that CVO, Cascade Volcano Observatory, and other Alaskan Volcano Observatory, they're very careful about how they release that and when an eruption could be imminent. Questions? All right, so lahars and pyroclastic flows are really the two big ones. And then lastly, lava flows, but they're not quite as dangerous for life as they are for infrastructure. So lava, you can outrun lava, but your houses, your towns can't. So when there have been situations in Hawaii, especially where whole villages are being inundated with lava, and people have to decide, should I move my house? Should I just let it go? Which is a very difficult decision to make. So even though you can outrun lava, your house could not necessarily, and that's more of the concern when it comes to lava. All right, so how do we know when a volcano is going to erupt? And really we don't, but there are some clues that we can tell if it might. One of the biggest things that have come out of satellites is looking at displacement of the eruption, or of the volcano, so we can actually see how the volcano is moving. So the most common way is live streaming. This has improved so much in the past few years. That site that I showed you before, we can just sit there and watch the volcanoes all day and see what's going on. And every volcano has, in the US, I should say, has a live stream enabled camera just to see what's going on. We can also monitor for earthquakes. And again, earthquakes and volcanoes, they sometimes go hand in hand, but these are different kinds of earthquakes. So we can actually feel the earthquakes when a magma is influxing underneath and causing the volcano to build in pressure. So we can actually monitor those earthquakes if the volcano is moving. We can also go out in the field, measure the plume of any ash that's coming out of the volcano. We can also measure the soil and water in that area. And this ground deformation, which is relatively new, this is Mount Etna over from 1992 to 2001. And you can see it's almost like it's breathing. So we have these different colors. So red is 15 centimeters up, purple is 10 centimeters down. And you can see using satellites how the volcano is going up and down. And we can correspond that with magma that could be influxing underneath and causing an increase in pressure and then a decrease in pressure. So understanding the magma is the first key to understanding what's going on with the volcano. So this is a relatively newer way to monitor the volcanoes, especially with now there's satellites everywhere. So much more helpful for us to see. All right, and we measure eruptions. Actually, we can use the volume of erupted material and how high the cloud gets, and just subjective observation. So it's almost like the Richter scale. We call it the VEI, the Volcano Explosivity Index. And when Mount St. Helens erupted in 1980, find my thing here. So it was a VEI of 5. It has had a few eruptions since then that have all been less than that. When Pinatubo and Krakatoa, they are VEIs of 6. Mazama, which is what created the Crater Lake caldera, and Tambora were both 7 VEIs. And Yellowstone caldera, which happened before humans were around to observe it, was a VEI of 8. So humans have never experienced a VEI of 8. The only reason we know about it is through the geologic record, and it would be an extremely devastating volcano should we have a VEI of 8. There's never been any kind of recording of anything greater than 8. That doesn't necessarily mean that it couldn't happen, but there's just no geologic evidence of that. Which brings me to Yellowstone, which I always get questions about Yellowstone. Should we be worried about Yellowstone? And my answer is a really non-answer, but you really shouldn't lose sleep over it, but you should be aware of it. So Yellowstone is a hotspot. Again, we don't know why hotspots form, but it's happening on under continental material. So again, we're getting that rhyolite. So granite is the intrusive version of rhyolite. So rhyolite and granite are stickier lavas. So there's lots of quartz in it. It adheres better to itself as opposed to the basalt. So we have larger crystals in rhyolite versus very fine grained crystals in the basaltic lava. So we have this magma plume, and it's interacting with continental material. So we're actually getting a change in chemistry of those magmas. So we're actually increasing the amount of quartz, changing the chemistry from more of a basalt to a more rhyolitic material. It's also a huge area. And as that magma pushes up, there's more material to kind of push through, which causes the whole area to pull apart, which causes a bigger footprint. So the entire Yellowstone caldera was so big that they couldn't even see that it was a caldera until we could get an aerial photo of the entire area. It's just such a massive, and you can actually see here, this is part of it, but there's a road. This is, I think, just the spring of it. It's not even the whole thing. But just such a massive area that you just couldn't see the whole caldera. So it will be very devastating if and when it erupts. So to give you a little bit of an idea of the history of it, Mount St. Helens, the ash made it to as far as maybe Montana, maybe just on the border. So the ash of Mount St. Helens did not make it across the country. The first eruption of Yellowstone was 2.1 million years ago, outlined here in red. So the plateau is right here by the Montana, Idaho, Wyoming border. So this was the area that we have records of the ash fall. Again, nobody was here to see this. It could have gone further depending on erosion. The Mesa Falls Tuff was 1.3 million years ago, a little bit of a smaller eruption from our record. And lastly, the Lava Creek which was 640,000 years ago. And that ash we've been able to trace all the way down to the Gulf of Mexico. Now, here in Illinois, we had glaciers that came through, and glaciers ripped up everything here. So there could very well have been ash as far as Illinois. We just don't have any geologic evidence of it. So we just don't know how far it would go. Yes?
So on the Mount St. Helens volcano, it seems like it was like a pretty evenly distributed area around it. With Yellowstone, it kind of seems like it only goes in one direction. So why is that? Like, why wouldn't it go just as far as the other direction?
Wind flow. Yeah, so you get the wind that's pushing. I mean, it's all going in that direction because that's the way the wind blows, I guess. Yeah, you go with the atmosphere, and you always get things going from west to east. So you'll see storms going from California across the country. So it just goes with the wind. And some of these ash clouds get up to 30,000 feet, which is up in that topmost atmosphere. So wrong direction, sorry. So the probability per year of an eruption is 1 in 730,000. So that's 0.00014%. Very, very, very small chance of an eruption per year. So I would say be aware of Yellowstone, know that it's a volcano, but I wouldn't be too worried about it. At this point, scientists don't think that there's enough material or pressure to cause an eruption to happen. And if we're going to put our concern into something, we should really be more concerned with climate change, which is already causing issues. We've got a drought. Hopefully it will rain tomorrow because we need it. Those are things that we should be more concerned about than worrying about Yellowstone at this point. So that's my little, don't worry too much about Yellowstone. Be aware, but don't freak out. And that's true for pretty much every volcano. We don't really have that much to worry about here in Illinois. But if Yellowstone did erupt, we would have effects of it. There is a chance that we could get ash here. And it would destroy our way of living at this point with air traffic. A lot of those, a lot of the area that would be inundated with ash is where we grow our crops and our. They'll take care of themselves with the San Andreas fault, but yeah. Anyways, so it would be devastating, but we're also talking like such a minute probability, and we're also talking geologic time, which is greater than just next year, 10 years, 20 years. You know, geologists tend to think tens of thousands to millions plus years. So think about time a little differently. All right, and so why should we love volcanoes? Because I love volcanoes. I think they're super cool. They help the earth. They help the earth cool off. So when the earth formed 4.3 billion years ago, it formed by all of the differentiation. So all of the nickel, iron core congealing, and then it creates a lot of heat. Volcanoes help get rid of the heat. It helps earth cool off. It also builds land for us. So, you know, maybe you could go ahead and for 10,000 years get a plot of land off the Leilani seamount that's forming off of Hawaii, and your great-great-great-great-grandkids could have beachfront property in Hawaii. So volcanoes create land for us, and they make our land more fertile. So we can use volcanoes for our landscaping and our building materials. A lot of people have seen that red scoria that we use in our landscape. It's got lots of good minerals in it. So lots of iron, lots of magnesium, very helpful for our plants. If you like coffee or chocolate, volcanoes are your friend. We get Kona blend from Hawaii because of the volcanoes. Colombia, lots of good coffee there, lots of good chocolate. So our agriculture does depend on volcanoes and the fertile soil of them. In Iceland, the entire country is run on geothermal energy. So all the electricity, all geothermal, because they have lots of volcanoes, they have lots of geysers, lots of heat just coming out of the earth, and so they've found ways to harness it. I was actually watching a woman, an American, move to Iceland, and she said their floors are all heated because of the geothermal energy. Their towel racks are all heated because of the geothermal energy. That's nice on a nice cold winter day to have nice heated floors, all because of the volcanoes. And honestly, because volcanoes are beautiful and everybody wants to go. So this is actually my mountain, Mount Bachelor, and Saul Butte and Cole Butte here and here. So I did study those three mountains, but this was the big one. And so they're beautiful, and we love looking at them and seeing them and exploring them. So why should we study them? Because they're really cool, and it's cool to say I'm a volcanologist and have people understand that you're not talking about Mr. Spock from Star Trek. So volcanoes are very helpful for us, as we know, but we need to learn about them. We need to understand when they could erupt and how to help people so that they don't get in the way. So we can improve in prediction abilities and then learn about the hazards and how, just the change from the 1600s to the 1900s, how much has changed and how people are dying from them has changed just because of an advance in technology. And we can learn how to protect people and our communities. So now the most important question, which is what happens if you throw someone in a volcano? Yes. But what happens to the volcano, I guess, is the question. So I want to preface this. This is not an actual person. This is a bag of rubbish. So it is not an actual person, but I want you to notice what's going on to the volcano itself when it erupts. So the very beginning, I mentioned that lava cools from the top down. So that was a really good example of how it looked like it was nice and calm on the top, but as soon as you broke that seal, if you will, it just started to erupt again. So if you choose to walk on lava, like I did, wear the right shoes and be careful of what's underneath. So. And this is, I'm not related to Disney Plus, so please just don't sue me, but this is a really good documentary about some very famous volcanologists. They were a husband and wife team. It's called The Fire of Love. It's on Disney Plus. And everything we know now about physical volcanology, we know because of these two. And unfortunately, they did pass away in, I believe, the Pinatubo eruption. But they really helped revolutionize our understanding of volcanoes and what's happening, what's physically happening. So I have a trailer for you to watch if you would like. And but before I start that, what questions do you have? Any questions? No questions? Okay, well then we'll just do this.
This is Katja, and this is Maurice. Tomorrow will be their last day. They will leave behind hundreds of hours of footage, thousands of photos, and a million questions. Alone, they could only dream of volcanoes. Together, they can reach them. They meet on a blind date at a cafe. From here on out, life will only be volcanoes, volcanoes, volcanoes.
C'est très dur, deux volcanologues qui vivent ensemble. Parce que c'est très volcanique, donc franchement, ça fait des éruptions très souvent.
For Katja and Maurice, the unknown is not something to be feared. It is something to go toward.
Moi, j'aime bien qu'il marche devant moi.
Proper
Je me dis,
shoes.
s'il va se tuer, je préfère être avec lui, donc.
Normalement, je l'ai réussi mieux que ça, franchement. Hein. Volcan, c'est le plus beau, mais ça tue. Un de mes rêves, c'est que les volcans ne tuent plus.
Katja and Maurice insisted that this type of close-up study had to be done.
Me fait remarquer que nous sommes fous de rester là. Et pourtant, nous restons.
In this world lived a fire, and in this fire, two lovers found a home.
So if you're so inclined or you would like to watch that, it is on Disney Plus. I do recommend it. It was a really enjoyable movie. So. And this is how I would like to end with the Amoeba people, which I started out with. But they do really awesome geology-themed songs. And if you'd like to dance like a Plinian eruption, we can all dance. What questions do you have for me? Yes.
79 AD.
Obsidian is actually closer to the rhyolite, so it's volcanic.
In a layer of hot, scalding ash and rock known as a pyroclastic flow. Nearly 2,000 years after the eruption, the preserved remains of the inhabitants of Pompeii.
It is,
A terrifying reminder of
I think it's higher. I think it has a higher quartz content than the rhyolite. Don't quote me on that, but it is, essentially it's volcanic glass. So it has a pretty, I think it's 75% silica, so quartz material, versus rhyolite, which is, I think, a little bit lower. So it also has to cool very quickly to become volcanic glass, to become obsidian. So it can happen in water, or it can just, the way that if it cools very quickly, then it can become that volcanic glass, as opposed to a rhyolite, which is going to cool a little bit slower. So,
another sobering reminder of the volcano's
yeah.
strength.
No, it was actually Pacaya, which, yeah, is unfortunately no longer there. From what I understand, it was 2006 that I went there, and it had just erupted in April, and I was there in August. So, yeah, my uncle was stationed in Guatemala, and I went to visit, and he said that it's not there anymore. So, which, yeah, but I think we went to Fuego, but we didn't collect there. So, yeah, there's tons of volcanoes in Guatemala. Yeah. That's a good question. I am not sure. Maybe well, I think you could still drill through. Could still drill through, I would think, but I don't know the answer to that. That's an interesting question. I have to think about that. Questions. So who's going to a volcano now? Right. Well, thank you again for coming, and I have my rocks up here. I'll be happy to talk about them. I actually have my sample from Iceland. I was able to, I was supposed to donate them all back to the college when I left, and this one happened to get stuck in my pocket. So, yeah, no, it was really fun going through customs, and when they were like, "What do you have?" and I'm like, "A few rocks." 93, but 93 rocks, yeah. All about this size, so, yeah. All right, thank you again.
For the record, Tacoma's not a town.
Kona?
Tacoma.
It's a city, yes.
It's the second largest city in Washington.
Yeah, I know. But they chose to sit, you were born, so did you do the Lahar things?
No.
Did you know about Lahars?
No, we didn't care. It was, I don't think it was classified as active until sometime in the 70s when we started seeing steam.
Ah, I see. Yeah, I will say I had some students, oh, thanks for coming. I had some students in my that I was teaching in grad school who did not know. They still didn't know. And I was like, you live right there. Like, you should.
They're actually more worried about tidal waves.
Yes, the tsunamis, yeah, for sure. I know, yeah.
I mean, I knew that when growing up, I knew that if Mount Rainier ever went, that we would be under 15 feet of mud.
Yeah.
But
1883.
Yeah.
Krakatoa, Indonesia. One of the loudest volcanic eruptions.
Oh, it's been,
Eruptions loud enough to be heard 3
I don't know off the top of my head, but it's not been in, I think Native Americans had recorded it, but I don't think like white settlers had, yeah. Again, geologists think about time vary. So it was recent, geologically speaking, but not. I'm not sure.
year 79 AD, Mount Vesuvius erupted, burying the nearby cities of Herculaneum and Pompeii in a layer of hot, scalding ash and rock known as a pyroclastic flow. Nearly 2,000 years after the eruption, the preserved remains of the inhabitants of Pompeii were discovered and excavated, a terrifying reminder of the volcano's awesome strength. Krakatoa, Indonesia, one of the loudest volcanic eruptions ever recorded. With an eruption loud enough to be heard 3,000 miles away, it resulted in a tsunami so large, more than 30,000 people perished as a result. Another sobering reminder of the volcano's awesome strength. In the year 79 AD, Mount Vesuvius erupted, burying the nearby cities of Herculaneum and Pompeii in a layer of hot, scalding ash and rock known as a pyroclastic flow. Nearly 2,000 years after the eruption, the preserved remains of the inhabitants of Pompeii were discovered and excavated, a terrifying reminder of the volcano's awesome strength. Krakatoa, Indonesia, one of the loudest volcanic eruptions ever recorded. With an eruption loud enough to be heard 3,000 miles away, it resulted in a tsunami so large, more than 30,000 people perished as a result. Another sobering reminder